In this video, we are going to talk about how to differentiate the inverse functions. What is an inverse function? Let's assume that we have a certain function, f of x. So this is the function f of x. And then this is also another function that contains some elements. Let's say g of x. So now, let's assume that this contains 1, 2, and 3. And then let's assume that f of x is working by a certain rule, which is x plus 2. So in this case, the first one will have 1 plus 2 is 3. So here will be 3. And then 2 plus 2 is 4. So here will be 4. And then 3 plus 2 is 5. So this place will be 5. So now, what will be the rule that would take us from g of x to back to f of x? So we move from f of x to g of x in the first instance. So we are looking for a certain rule that is going to take us from g of x back to f of x. And you see that if we use x minus 2, now if we do 3 minus 2 is 1, so we get the first entry. Then 4 minus 2 is 2, so we get the second entry. And then 5 minus 2 is 3, so we get the third entry. So now you see that g of x, if you put the entries in g of x back into this function, we'll get back f of x. So we say that g of x is the inverse of f of x. And then, so the inverse function is the function by which if you perform an operation, you are going to get back f of x. So now, if we were to sketch a graph, we were to show this on a graph, then let's assume that this is our graph, and then this is 2, and then this is minus 2. So we said that f of x is a graph of x plus 2, so it's a linear graph, so it's going to cut this axis. And then g of x is x minus 2, so it's also going to cut through this axis, and these are parallel lines. So more often, if a graph can be reflected in the line y equals x, it's an inverse function. So now, let's assume that f of x is equal to 3x. What will be the inverse of f of x? What we will do is that we say let y to be equal to f of x, which is equal to 3x. Then what we'll do is that we swap the position of x and y. So in this case, it's going to be x equals 3y. Then we solve for y. So we divide both sides by 3 and divide here by 3. So y is equal to x over 3. So y equals x over 3 is the inverse of f of x equals 3x. So in other words, y will be g of x, as in this case. So g of x is equal to x over 3. If we are to represent this on a graph, let's show this on a graph, so that here's y and then here's x. So f of x equals 3x is going to look like this. This is f of x equals 3x. And then f of x, so f of x equals 3x. And then g of x equals x over 3 is going to look like this. So this is the graph of g of x equals x over 3. Now, what if instead of x over 3, it was f of x equals x squared? So we need to find g of x, which is the inverse of f of x. So what we'll do is that we'll say let y to be equal to x squared. Then we'll interchange y and x. So in this case, x is going to be equal to y squared. Then we'll solve for y. So in this case, we just take the square root on both sides. And therefore, we find out that y is equal to root x. So now, let's sketch this on a number line. Let's first sketch f of x. So f of x equals x squared. So this is the graph of f of x equals x squared. So this is f of x. Now, what is g of x? Remember that this root x is g of x equals y, which is equal to root x. Now, there is something I need to bring to your notice here. You see that f of x passes the vertical line test. Any vertical line you draw on this graph will touch the graph of f of x at only one point. However, if you draw horizontal line, f of x fails the horizontal line because a horizontal line would touch this graph at 2 points except at x equals 0. And because it fails the horizontal line test, it means that this graph will fail the inverse test. And also, what it also means is that this graph is not one-to-one. So this is where we need to be bringing the limits. We need to restrict the boundaries for our inverse functions. Now, remember that when we spoke about functions, we said that in terms of relation, a one-to-one relation is a function. And then we also said that a many-to-one relation is also a function. However, for inverse functions, it is only a one-to-one relation that will pass or qualify for inverse function. But a many-to-one relation will not pass for inverse function. So in this case, if we were to sketch the graph of y equals root x, it's going to look like this. So this is the graph g of x equals root x. However, you see that if we were to extend it, it will have this part, which will not pass for a function, and therefore we need to restrict it to x greater than 0. So now, remember what we said. We said that if we have a function f, and then we put in a certain domain x values, we are going to get g of x. Now, if we put g of x back into f, so we find f of g of x, f of g of x, then it is going to give us our original domain, which is x. So f of g of x is equal to x. Now, let's find the derivative of both sides. So let's differentiate both sides, which is d dx. So if we differentiate both sides, you see that this is a composite function. So we'll first differentiate f. So if we differentiate f of x, we'll get f prime of g of x. So this is f prime of g of x. Then you differentiate what is inside, which is times g prime of x. And then when you differentiate x, you will get 1. So now remember that we've already established that g of x is the inverse of f of x. And we want to find the derivative of the inverse function. So we need to make g of x the subject. So by dividing through by f prime of g of x on both sides, we divide here too by f prime of g of x. So in this case, we find out that g prime of x is equal to 1 divided by f prime of g of x. So this is a very important formula to remember. The formula for finding the derivative of inverse functions. The derivative of an inverse function is equal to 1 over the derivative of the original function evaluated at the inverse function. So let's apply it in some examples and then we'll see how to use this formula. So now let's assume that f of x is equal to x squared for x greater than 0. What is the derivative of the inverse g prime of x? So now let's first find the inverse, which is g of x. So remember what we said. We said let y to be equal to f of x, which is equal to x squared. So y is equal to x squared. And then we said we should exchange x for y. So that means x is equal to y squared. And we should solve for y. So you find square root of both sides. And we find out that y is equal to square root of x. So now we now know that j of x, which is equal to the inverse of f of x. Now, I want you to see that there is difference between this y equals f of x and this y. This y is just y for the original function, but this y is the inverse function g of x. So in this case, the inverse function g of x is equal to root x. So now f prime of x is equal to, we differentiate x squared, that will be 2x. So now we then need to use this formula. So we know that j prime of x is equal to 1 over, which is 1 over f prime of j of x. F prime of x is 2x, so it will be 2. Then j of x is root x, so 2 root x. That is the final answer. So the derivative of the inverse of x squared is 1 over 2 root x. Now, let's check our answer from here. Remember that we said the inverse is root x. So let's find j prime of x from here. So root x can also be written as x exponent 1 over 2. So if we differentiate this, d dx of x exponent 1 over 2 is equal to, you bring the power down, which is half, exponent half minus 1, that will be minus half. And this is the same as 1 divided by 2 root x. So you see that if we go by this rule, we'll get back the same answer. F of x is equal to x squared minus 5. And j of x is the inverse of f of x. Find j prime of x. So now, we know that f of x is equal to x squared minus 5. So let's find the inverse of f of x. So let's let y to be equal to x squared minus 5. So we exchange y and x. So x is equal to y squared minus 5. So therefore, if we add 5 to both sides, we find out that y squared is equal to x plus 5. And then if we find the square root on both sides, we find out that y is equal to square root of x plus 5. Now, I didn't bring plus or minus because we are talking about inverse function. A function must only have one value in the codomain, and therefore we don't need to bring plus or minus in this case, else it will cease from being a function. So now, this implies that j of x, which is the inverse of f of x, is equal to root x plus 5. So let's find f prime of x. F prime of x is equal to, we need to differentiate x squared minus 5. If we differentiate x squared, you get 2x. And if you differentiate minus 5, you get 0. So now, we know that j prime of x, which is equal to 1 divided by f prime of j of x. So this is equal to 1 divided by f prime is 2x, 2 times, then x is root x plus 5. So this is the answer. Let's check whether our answer is correct or not. So now we found j of x to be equal to root x plus 5. Now we can also write this as into bracket x plus 5 exponent half. Now let's find j prime of x from this place. So you bring the half down, which is 1 over 2, then times x plus 5. Then you subtract 1 from the half, which becomes minus 1 over 2. So this becomes 1 divided by 2 times root x plus 5. So you see that we get back this same answer that we use the formula to get. If f of x is equal to s cubed plus 1, find the derivative of f inverse of x. So f of x is equal to x cubed plus 1. So let's find the inverse of f of x. So let y to be equal to s cubed plus 1. Now, interchange x and y, which will make x is equal to y cubed plus 1. Then now solve for y. So we can bring 1 here. It becomes x minus 1 equals y cubed. So y is equal to the cube root of x minus 1. So this means that f inverse of x is equal to cube root of x minus 1. Now let's find f prime of x. That is equal to, if you differentiate x cubed, you get 3x squared. Then if you differentiate 1 is 0. But remember that g prime of x is equal to 1 divided by f prime of g of x. So our g of x in this case is f inverse of x. So g of x in this case is equal to f inverse of x. Remember that we said g of x is the inverse of f of x. So in this case, f prime inverse of x is equal to 1 divided by f prime of g of x. So now f prime is 3x squared. So this becomes 3 times. We found x as cube root of x minus 1 squared. So now, this is a cube root. So f inverse prime of x is equal to, now cube root can also be written as x minus 1 exponent 3. So exponent 1 over 3. So this will become 1 divided by 3 times into bracket x minus 1 exponent 3, 2 over 3. F of x is equal to x cubed minus 9x squared plus 27x minus 27. G of x is the inverse of f of x. Find g prime of x. So now we know that g prime of x is equal to 1 divided by f prime of g of x. So we need to first find g of x. So now f of x is equal to x cubed minus 9x squared plus 27x minus 27. To be able to find g of x easily, we need to find a way of factorizing this polynomial. But you see that this polynomial is f of x equals x minus 3 cubed. Now let's expand this and see whether we are right. Using Pascal's theorem, we are going to use the factors 1, 3, 3, 1. So this becomes s cubed, then plus 3 times x squared times minus 3, then plus 3 times x times minus 3 squared, then plus minus 3 cubed. So this becomes x cubed, then 3 times minus 3 is minus 9. So this becomes minus 9x squared. Then minus 3 squared is 9 times 3 is 27, so plus 27x. Then minus 3 cubed is minus 27. So we get back our original function, f of x, and this is equal to f of x. So it implies that f of x is equal to x minus 3 cubed. So now, since we found f of x, then let's replace f of x with y and find the inverse. So y is equal to x minus 3 cubed. So let's exchange x and y. So x is equal to y minus 3 cubed. So we can solve for y in this case. So we find cube root of both sides. So cube root of x is equal to cube root of, into brackets, y minus 3 cubed. So y minus 3 is equal to cube root of x, and therefore y is equal to 3 plus cube root of x. So this implies that g of x is equal to 3 plus cube root of x. So having found g of x, then we can then use the formula to find g prime of x. So we found g of x as equal to cube root of x plus 3. But we know that g prime of x is equal to 1 divided by f prime of g of x. But we know that f of x is equal to x cubed minus 9x squared plus 27x minus 27. So let's find f prime of x. And this is equal to 3x squared, then minus 18x, then plus 27. So using this formula, we can then find g prime of x. So g prime of x is equal to 1 divided by, now we found g of x as cube root of x plus 3. So this becomes 3 times 3 plus, now the cube root of x, I want to write this as x exponent 1 over 3 all squared. Then here's minus 18x, so minus 18 times 3 plus x exponent 1 over 3. Then the last one is plus 27. But now we can further simplify this. So let me take the denominator alone. So taking the denominator alone, let me solve that here. It is 3 times 3 plus x exponent 1 over 3 squared. Then minus 18 times 3 plus x exponent 1 over 3. Then plus 27. So now let's expand this. This becomes 3 times 3 squared is 9 plus 2 times 3 is 6. So here is 6x exponent 1 over 3. Then plus x exponent 1 over 3 squared becomes x exponent 2 over 3. Then minus 18 times 3 is 54. Then minus 18x exponent 1 over 3. And then plus 27. So now 3 times 9 is 27. Then 3 times 6 is plus 18x exponent 1 over 3. Then plus 3 times x exponent 2 over 3. Then minus 54. Then minus 18x exponent 1 over 3 plus 27. So in this case, you can see that 27 plus 27 is 54. And then 54 minus 54 is 0. And then here's plus 18x exponent 1 over 3. And here's minus 18x exponent 1 over 3. So at the end of the day, what will be left will be 3x exponent 2 over 3. So g prime of x is equal to 1 divided by 3x exponent 2 over 3. Remember that we said g of x is equal to cube root of x plus 3. So let's find g prime of x. But then let me write g of x as x exponent 1 over 3 plus 3. So g prime of x is equal to, bring 1 over 3 down, which is 1 over 3x. Then subtract 1. If you subtract 1 from 1 over 3, you get minus 2 over 3. And if you differentiate 3, it is 0. So g prime of x in this case is equal to 1 divided by 3x exponent 2 over 3, which is the very result we got from the first instance. And therefore, our answer is correct. So g prime of x is 1 over 3x exponent 2 over 3. Find f inverse prime of a, given f of x equals x exponent 5 minus x exponent 3 plus 2x at a equals 2. So f of x is equal to x exponent 5 minus x exponent 3 plus 2x. So now, at a equals 2 means that f of x is equal to 2. In other words, x exponent 5 minus x exponent 3 plus 2x is equal to 2. So now, to be able to find the value of x for which f of x is equal to 2, we can just try some values. So let's find f of 1 is equal to 1 exponent 5, then minus 1 exponent 3 plus 2 times 1. 1 exponent 5 is 1, minus 1 exponent 3 is 1, plus 2 times 1 is 2. So the answer is 1 minus 1 is 0 plus 2. So this is equal to 2. So you see that f of 1 will give us 2. And therefore, it implies that f inverse of a is equal to 1. So now we can then use the formula. We know that f inverse prime of a, in this case of 2, is equal to 1 divided by f prime of f inverse of 2. So now let's find f prime of x. This is equal to, if you differentiate x exponent 5, you get 5x exponent 4. And if you differentiate x cubed, we get minus 3x squared. If you differentiate 2x, you get plus 2. So it means that f inverse prime of 2 is equal to 1 divided by. Now, we said that f inverse prime of, let me change this a to 2, of 2 is 1. So that means that anywhere you see x here, you insert 1. So 1 divided by 5 times 1 exponent 4 minus 3 times 1 squared plus 2. So this is equal to 1 divided by 1 exponent 4 is 1 times 5. So it becomes 5 minus 1 exponent 2 is 1 times 3 is 3, then plus 2. So this becomes equals to 5 minus 3 is 2. 2 plus 2 is 4. So the answer is 1 divided by 4. So if f of x is equal to 2x plus cos x, and g of x is equal to f inverse of x, find g prime of 1. So now f of x is equal to 2x plus cos x. So now g prime of 1 implies that f of x is equal to 1. So this means that 2x plus cos x is equal to 1. So what value of x that when we put in this function we'll get 1? So let's try f of 0. So this becomes 2 times 0 and plus cos 0. Now 2 times 0 is 0 and plus cos 0 is 1, and this is equal to 1. So this means that g of x is equal to 0. This is 0. So because it is 0, that will give us f of x equals 1. Now, having found this, then we can put it into the formula. We know that g prime of x is equal to 1 divided by f prime of g of x. So in this case, it's g prime of 1. So g prime of 1 is equal to 1 divided by f prime of g of 1. We know that g of 1 is equal to 0. So now let's find f prime of x. If you differentiate 2x, you get 2 plus. If you differentiate cos x, you get minus sine x. So f prime of x is equal to 2 minus sine x. So now g prime of 1 is equal to 1 divided by. Anywhere you see x in this function, you put in 0. So it becomes 1. G prime of 1 is equal to 1 divided by 2 minus sine 0. And then sine 0 is 0. 2 minus 0 is 2. So this becomes 1 over 2. And therefore, g prime of 1 is equal to 1 over 2.